Well, hello everybody. As you can see, it's the bonus quiz for 5.3. It's actually a three-pointer because I've added some spice. Problem 3 is a review problem drawn from Chapter 2 to keep you remembering what you've already learned. So we'll get there soon enough. This first problem, they ask us to factor out a factor. And that makes perfectly good sense to me. They want us to factor out a factor with a negative coefficient. Now that's, in a sense, a new station. And it becomes a primary skill as we move forward into Chapter 5 and especially Chapter 6. They want us to factor out a negative number from these three terms. And I'm looking for a negative number that all three terms have in common, and I don't see anything. But there's one that they always have in common. You know that they always have a common factor of 1. Believe it or not, and this is a bit sneaky, they also have a common factor of negative 1. And so that's what I'm going to pull out from all three terms. I'm going to factor out a negative 1. And I ask myself, what gets left behind? Now, remember when we were multiplying by negative 1 into some parenthesized quantity? I call that minus parentheses, and I wanted you to figure out a slick way to handle it. And it turns out multiplication by negative 1 or minus parentheses is simply a sign changer. Well, it's the same idea when you're going in the opposite direction. Basically, we're not multiplying by negative 1. We are dividing by all three terms by negative 1. We are pulling a negative 1 out from all three terms, and that's a sign changer too. And so all three terms are simply going to toggle their signs. The minus r to the fifth becomes a plus r to the fifth. The plus 2r to the fourth becomes a minus 2r to the fourth. And the minus 4 becomes a plus 4. And lo and behold, I've factored out a negative 1 from all three terms. And you can always generate. What we've done is we've massaged this expression into this form here, and these are two equivalent expressions. So I ought to be able to get back and forth. So if I do this multiplication, I ought to get back my original expression. And you could go ahead and multiply everything by negative 1, and of course you're going to get back the original expression. So the idea there, though, is factor out a negative 1. And what this section is doing, one of the small tasks that it's preparing you for, is, well, something like this, which we're going to see very shortly in chapter I think it's 5.4 and 5.5, where we're given trinomials like this. And whenever you have a trinomial, and notice this is arranged in descending order, whenever you have a trinomial, you're going to be asked to crack it, to factor it. And if the first term here has a negative, it is always a very super smart thing to do to factor out a negative number so that the leading term here is positive. And so I'll factor out a negative 1 from this, and I would simply toggle the signs of everything inside here. And now the recipe they give us for factoring a trinomial works so much easier on this should have been a square, works so much easier on trinomials that have that begin with a positive coefficient, in this case like this. So even in chapter 6, though, you're going to be factoring out a negative 1 when we're dealing with fractions. So I've already put in the answer for this one, and again, this is just a prep for what's coming down the road, factoring out a negative 1. Let's take a look at the second problem here, and this is more the essence of this particular section. What they're asking us to do here is to factor a term, an expression that has 4 terms, a quadrinomial, if you will. So here is the expression. It is not an equation, and we're going to factor it. And this is one of the major moves in chapter 5, and it's taught pretty much a standard way everywhere. I do have a hack that is far superior to the way it's taught, and I'm going to go ahead and put that up here, the link for that up here. If you have time and you want to learn a better way of doing this and you're comfortable factoring trinomials, check that link out. I'm going to do this the standard way just in case you don't want to learn the hack. And so here is the way to do these things, is to, whenever you have 4 terms, and this is going to be true for calculus and college algebra, whenever you have 4 terms, always start out by arranging things in descending order. It's a nice way to bookmark a starting position. And so I'm going to write this in descending order. 3, 2, 1, and then x to the 0. And then what you want to do when you have 4 terms is you want to circle the first 2 terms, make a dance couple out of them, and do the same thing for the second 2 terms. Now this is pure technique on how to factor a quadrinomial. What's called factoring by grouping. And so I've grouped the first 2 and I've grouped the second 2. Now this first group, look to take out the biggest bite possible from both of these terms. And I think you can see it's going to be an x squared. I'm going to factor an x squared out from both of these terms, and so that means I got an x here and a negative 2 here. Notice if I do the multiplication, I get this back, and so it checks. I factored the biggest bite out possible, which was a x squared. And now what you want to do, and this is a secret ingredient, is you look at this binomial here and you want to duplicate it over here. You want there to be an x minus 2 over here. And so what do you have to factor out to get an x minus 2 over here? And I think you see it's a minus 5. If I pull a minus 5 out, it is going to multiply back negative 5x, and negative 5 times negative 2 is a positive 10, so it works. So pulling out a negative 5 leaves a binomial behind that is exactly identical to this one. And now here is an interesting move. What we have here are 2 terms. Here's the first term, and here is the second term, and there's a connector between them. These 2 terms have this factor in common. And so I'm going to pull out an x minus 2. Pull out an x minus 2. That means I'm going to factor this out from the first term, factor this out from the second term, and ask myself what got left behind. And the answer is x squared minus 5. So that is sort of an inside-outside move. It's very tricky, and if students are going to get hung up, that's where they get hung up. And in fact, the textbook in Math Excel starts you from this position, getting you trained in pulling out these binomials before giving you the full problem here and asking you to work from top to bottom. So, do we see that answer over here? X squared minus 5, yes. X minus 2, yes. So let me go ahead and click answer D. And now we get on to the review problem. And this is going to be a graphing problem. And this is what I called those freaky lines. That is, as a review, you remember, you can always replace f of x by y, and I'm going to do that to show you that I have y is equal to some constant, which I called one of those freaky lines. The constant here happens to be negative 3. And so there's a constraint here that says y has got to be negative 3, but there's no constraint on x. So y has got to be negative 3. X can be anything. Y has got to be negative 3, and x can be anything. And so we might as well choose simple anythings. I'll choose 0 here, and 1 here, and 2 here. X can be anything, but y has got to be negative 3. So that was the technique for handling lines where you had y is equal to a constant, or where you had x is equal to some constant. You simply generate some ordered pairs with the given constraint. In this case, y had to be negative 3. It says nothing about x, so x can be anything. And then when you graph these points, of course, what you're going to get is 0 over and negative 3 down, 1 over and negative 3 down, 2 over and negative 3 down. You're going to get a horizontal line. And so that's the answer. Remember, I had a video where I showed a really quick hack for this, and that is, you look at this part right here. This says y has got to be negative 3, x can be anything. So y has got to be negative 1, negative 2, negative 3, but x can be anything to the left or the right. And there is the line right there. So all that's left to do is to actually use the tools inside Math Excel to graph that. And I will put a point there, and it doesn't matter, I'll put it here. And that's it. I'm happy. We submit. And lo and behold, 3 green arrows. Okay, I hope that helps. I'll be talking to you again soon.